Hello everybody, I'm Darian Garland and I'll be your facilitator when we talk about tropical storms. Right? But by the end of this lesson you'll be able to identify tropical storm season, what the requirements are for tropical storms to form and to dissipate. First thing you need to know is the season. Does anybody know it yet? Alright, tropical storm season is June 1st to November 31st of every year. In the Atlantic Ocean, hurricanes form. In the Pacific Ocean, typhoons form. They have the same structure, same requirements. They're only in different oceans, so they have a different name. Down in Australia, those crazy Aussies, they call them willy willies. If you ever go to the land down under, now you know. Right, let's move to the board. We'll talk about requirements for formation. Weak vertical wind shear. Storms don't like resistance, they don't like wind, they don't like anything but the path of least resistance. If you throw wind, for example, like in the form of a cold front, the storm is going to veer into a different direction. It needs to be over a large ocean area. There needs to be lots of moisture and warm waters. Warm waters need to be 80 degrees Fahrenheit for a depth of 200 feet to provide that fuel to fuel that storm. Low-level convergence, that simply means that winds need to be pushing together at the surface to create upward vertical motion. We call that the chimney effect in weather. The storm will form poleward of 5 degrees north latitude. And it's far enough from the equator so when the Earth spins, it creates Coriolis effect, the partial spin, and it creates that upward vertical motion and the juice it needs to create that and intensify that storm. Now just the opposite will dissipate these storms. The storm moves over land, it doesn't get that fuel it needs via water. If it moves over colder water, you're not getting that warm air to fuel that storm. Again, increased wind shear will tear the storm apart. Example is if a cold front moves through, the storm is going to go straight away from that cold front. And if the storm moves equatorward back towards the equatorward to 5 degrees north, that Coriolis effect won't be happening and the storm will lose its spin. Right. Primary formation area is going to be off the coast of Africa near the Cape Verde Islands. Right here. Right. Lots of warm water. Thunderstorms come off of the coast all the time, which give you a pre-existing disturbance to start to fuel the storm. Also, there's a jet stream called the tropical easterly jet over Africa, and it's the only jet in the world that blows from east to west, and it blows right onto the Atlantic, and it provides that upward vertical motion that we were talking about to kickstart the storm, so to speak. Right? If you watch the video of Hurricane Katrina, it formed up in the Atlantic near the Mediterranean, and it moved into the Gulf of Mexico. You'll notice that when it moves into the Gulf of Mexico, it explodes. It gets huge. It starts getting lots of warm fuel. It's because the Gulf of Mexico is such a small body of water compared to the Atlantic Ocean. It's very easy to warm, kind of like a bathtub. And it just sits there. It's very steady, stable water. And it's warm, very warm in some cases, and it'll just blow storms up. We'll go back to the board and we will go through the life cycle of the storm. It starts out as a tropical disturbance, a very unorganized storm with little circulation. The storm starts to get fuel, it starts to spin. It turns into a tropical depression. And you can see in this picture, it's a little more organized. You can kind of see the spin, but it's still not very intense. The tropical storm is where the storm will receive its name. It becomes more organized, gets more developed because it's getting the ingredients that it wants. And finally, a storm turns into a hurricane. It has a well-developed eye. That is the key indicator for a hurricane, that eye. It's actually, the eye is the calm of the storm. There's no weather in the eye. The wind is very low. There's no rain, no clouds. The storm spins and has these outward bands. And keep in mind, these outward bands of these storms can be 600 plus miles across. They're very large storms. And you'll notice when you watch the Hurricane Hunters video of Noah flying into the hurricane, you'll notice how the plane rattles and they break through the eye wall. You'll see the change in weather. It's a very neat thing that they're able to fly through those storms safely. And as you may or may not know, storms are given categories once they become hurricanes. Typhoons are given categories too, but they're a little bit different than this. We're only going to talk about hurricanes because in North Carolina, that's what affects us the most. We don't ever get affected by a typhoon. We have the Saffir-Simpson scale 1 through 5. Saffir-Simpson scale is based off of these wind speeds in miles per hour. Also, let's say a Cat 2 only has a wind speed of 85 miles per hour, but it has increased damage and might get moved up after the fact to a Category 3. So we'll talk more about this based off your input in class. All right, please bring your ideas, your thoughts, your suggestions, and be prepared to share with the entire class. And I'll see you then.